Next is how to expand tan of theta 1 plus theta 2 plus so on to theta n. For this, first of all, we have to find some terms, and these are denoted by S1, S2, S3, S4 and so on. Let us explain S1 first. Suppose we have two terms or two roots, tan theta 1 and tan theta 2. Then S1 is summation tan theta 1 means tan theta 1 plus tan theta 2. Then S1 is summation tan theta 1. If we have three roots, say tan theta 1, tan theta 2 and tan theta 3, then S1 is tan theta 1 plus tan theta 2 plus tan theta 3, and again it can be written as summation tan theta 1 and so on. We have to take tan 1 times. Now S2 is summation of tan theta 1 into tan theta 2, means we have to take product of two roots at the same time. If we have three roots, say tan theta 1, tan theta 2 and tan theta 3, then S2 will be tan theta 1 into tan theta 2 plus tan theta 2 into tan theta 3 into and so on. So we have formula for tan of theta 1 plus theta 2 plus so on to theta n equals to S1 minus S3 plus S5 minus so on, divided by 1 minus S2 plus S4 minus so on. Kindly note first thing, signs are of alternative signs in numerator as well as in denominator. And kindly note second thing, that we have to take odd terms in numerator and even terms in denominator. Let us see one question based on it. If alpha, beta, gamma are the roots of equation x cube plus px square plus qx plus p equals to 0, prove that tan inverse alpha plus tan inverse beta plus tan inverse gamma equals to n pi radians, except in the particular case, and point it out. Solution. See, we have cubic equation. As it is of power 3, so it will have 3 roots, and you have to consider these roots in the form of tan. Let us see its solution. Let alpha equals to tan theta 1, beta equals to tan theta 2, gamma equals to tan theta 3. As we have 3 roots, so let these roots be of the form tan theta 1, tan theta 2 and tan theta 3. So we have theta 1 as tan inverse alpha, theta 2 as tan inverse beta, theta 3 as tan inverse gamma. Now the equation is x cube plus px square plus qx plus p equals to 0, plus p equals to 0. Its roots are alpha, beta, gamma, that is tan theta 1, tan theta 2, tan theta 3. Now next step is to find the value of S1, S2 and S3. See how we will find it. I hope you all remember, if equation is quadratic, ax square plus bx plus c equals to 0, and if roots are alpha and beta, then sum of roots, that is alpha plus beta, will be minus b over a. And in case of cubic equation with roots as alpha, beta and gamma, then sum of roots will be alpha plus beta plus gamma, that will again equal to minus b over a. Now if equation is quadratic, then product of roots, that is alpha into beta, is c over a. Similarly, in case of cubic, same thing happen, product of roots will be c over a. Sum of roots taken 2 at a time will be c over a, and at the last product of roots will be d minus d over a. Now see S1. S1 is summation alpha, means sum of roots taken 1 at a time, that is summation tan theta 1 will be minus b over a. B means coefficient of x cube, coefficient of x square, and a means coefficient of x cube. Here coefficient of x square is minus b, coefficient of x square is minus b, and coefficient of x cube is 1. Therefore, it will become minus p over 1 means minus p. Now see S2. As there are three roots, there will be three possibility. First is sum of all roots S1. Second is sum of roots taken two at a time, that is S2. And third is product of roots, that is S3. Now we will find S2. That is summation alpha into beta, means summation tan theta 1 into tan theta 2, and its value is c over a. C is coefficient of x, a is coefficient of x cube, so its value will be q over 1 means q. Now we will find S3, that is alpha beta gamma, that is product of roots, that is tan theta 1 tan theta 2 tan theta 3, that is minus d over a. Here d is p and a is 1, therefore it is d means constant term, here constant term is p, therefore it will be minus p. As we have three roots, so we will be having three values here, S1, S2 and S3. So it depends upon number of roots. If we have biquadratic equation, then we have four roots, S1, S2, S3 and S4. Now according to formula of tan of theta 1 plus theta 2 plus theta 3 is, see first of all alternative signs in numerator and denominator, and odd terms in numerator and even terms in denominator. So we have S1 minus S3 over 1 minus S2. Substituting all the values of S1, S2, S3, we get minus p plus p over 1 minus q. Minus p plus p will be cancelled out and we will get 0 over 1 minus q. We know 0 over something equals to 0. But kindly keep one thing noticed or one thing in mind, that 1 minus q must not be equal to 0. If this is 0, then it becomes indeterminate form, 0 over 0. This is the solution, but we have to find one particular case as asked in the statement. Unless q equals to 1, in which case the fraction takes the indeterminate form 0 over 0. As if we have q equals to 1, then it becomes 0. So it becomes 0 over 0 form, which is indeterminate form. Now leaving out the exceptional case, we have tan of theta 1 plus theta 2 plus theta 3 equals to 0. Now we want to find its general form in pi radians. Now this equation will be satisfied when theta 1 plus theta 2 plus theta 3 will be n pi radians, as tan of theta 1 plus theta 2 plus theta 3 equals to 0 when it is n pi radians. Therefore, value of theta 1 is tan inverse alpha, value of theta 2 is tan inverse beta, value of theta 3 is tan inverse gamma. Hence, tan inverse alpha plus tan inverse beta plus tan inverse gamma equals to n pi radians, except when q equals to 1.